my second lecture regarding the magnetism. We have learned about magnetization of material or intensity of magnetization. Secondly, we have studied magnetic intensity. Then we studied magnetic susceptibility. Then we studied magnetic relative permeability and Curie's law. Now today we are going to study another articles regarding the magnetism. Different substances or different materials are classified into different types. So, on the basis of magnetic properties, the different materials are classified into three categories. Or Faraday classified different materials again into three groups on the basis of their behavior in non-uniform magnetic field, and hence on the basis of magnetic properties or on the behavior of materials in non-uniform magnetic field, different substances are classified into three types. And first type is called as diamagnetic substances. Second type is called paramagnetic substances, and third type is called ferromagnetic substances. Now, substances which are weakly or feebly repelled by a magnet are known as diamagnetic substances. The substances, those are weakly or feebly attracted by a magnet, are called as paramagnetic substances. And substances, those are strongly attracted by a magnet, are called ferromagnetic substances. So depending upon the magnetic property of attraction or repulsion, diamagnetic substance means substance those are feebly repelled by a magnet. Paramagnetic means those substances which are feebly attracted by a magnet, and paramagnetic substances mean those substances which are strongly attracted by a magnet. Then the another properties of these substances are, so the substances those are feebly repelled, that means substances whose atoms have large number of paired electrons. So the atoms, the substance whose atoms have large number of paired electrons, they belong to the type diamagnetic substances. So for example, the substances such as copper, gold, silver, mercury, antimony, bismuth, water, hydrogen, alcohol, nitrogen belongs to diamagnetic materials. So the diamagnetic materials are also the substances whose atoms have large number of paired electrons. And the examples we have seen: copper, gold, silver, mercury, antimony, bismuth, hydrogen, alcohol, etc. In case of paramagnetic substances, those substances whose atoms have few unpaired electrons. So the substance whose atoms have few number of unpaired electrons are called paramagnetic substances. And the examples of these paramagnetic substances are aluminium, chromium, platinum, calcium, liquid of oxygen, tungsten, etc. So the substance whose atoms have few unpaired electrons are called as paramagnetic substances, and the examples are given. Similarly, the ferromagnetic substances, those substances whose atoms have large number of unpaired electrons belongs to ferromagnetic substances. So the examples of ferromagnetic substances are iron, nickel, cobalt, gadolinium, dysprosium, ferric chloride, or iron, nickel and cobalt and their alloys. So, from the examples of diamagnetic material, paramagnetic material and ferromagnetic material, here we observe that diamagnetism and ferromagnetism belongs to three types of matter such as solid, liquids and gases. And in case of ferromagnetic material, here only examples are from solids. The next property of these substances is if diamagnetic substance is placed in non-uniform magnetic field, then it has a tendency to move from strong magnetic field to weak magnetic field. So the diamagnetic substances are those substances which have a tendency to move from stronger part of field to weaker part of the field. In other words, we say that when diamagnetic substance or material is placed in non-uniform magnetic field, then it is repelled repelled from a strong magnetic field. If paramagnetic substance is placed again in non-uniform magnetic field, then it has a moderate tendency to move from weaker part to stronger part of the field. Or in other words, we can say that when paramagnetic material is placed in non-uniform magnetic field, then it gets attracted towards the region of strong magnetic field. Similar is the case for ferromagnetic material. If ferromagnetic material is placed in non-uniform magnetic field, then it has a very strong tendency to move from weaker part of the field to stronger part of the field. Or in other words, we can say that if the ferromagnetic material is placed in non-uniform magnetic field, then it gets attracted towards the region of strong magnetic field. The next property is, if the diamagnetic substance is placed in uniform external magnetic field, then the magnetic dipole moments are aligned in the direction opposite to that of external uniform magnetic field. That means a diamagnetic material, when placed in uniform external magnetic field, it gets magnetized in a direction opposite to that of direction of applied field. That means the direction of field is towards right, then magnetic dipole moments are in the left direction. So they are oppositely directed, M and B, in case of diamagnetic substances. In case of paramagnetic substance, if the paramagnetic substance is placed in uniform magnetic field, then suppose this is the paramagnetic sample and we have applied the magnetic field from left to right, then the magnetic dipole moments of each atom or atomic magnets are in the same direction as that of the magnetic field. That means we say that if the paramagnetic substance is placed in uniform external magnetic field, it gets feebly magnetized in a direction of applied external magnetic field. Similar is the case if a ferromagnetic material is placed in uniform external magnetic field, then it gets strongly magnetized in the direction of applied external magnetic field. So, in uniform magnetic field, diamagnetic substances are magnetized in a direction opposite to the direction of magnetic field. Paramagnetic substances are feebly magnetized in a direction of external magnetic field, and ferromagnetic substances are strongly magnetized in the direction of applied external magnetic field. In short, we say that we know a cowboy takes some cows and go outside the home. Then in the hand of the cowboy there is a stick. That means the stick is the symbol of magnetic field. If the stick is shown to the cows, then cows go in one direction. But their speed is very slow. That means they are behaved like a paramagnetic material. If the cowboy stick is again a magnetic field and all the cows are go in the direction of magnetic field very fast, then they are ferromagnetic substances. But instead of cow, if there is ox or some undisciplined cow, then as the cowboy shows the stick, that means magnetic field is applied towards the cow, the cows come towards the cowboy, which is the same case as that of diamagnetic substances. Then third or next property of diamagnetic substance. If a thin rod of diamagnetic substance is placed in uniform magnetic field, suppose the thin rod is suspended with the help of thread in uniform magnetic field, then it comes to rest with its length perpendicular to the direction of magnetic field. In case of paramagnetic substances, if a thin rod of paramagnetic material is placed in again uniform magnetic field, then it comes to rest with its length parallel to the direction of magnetic field. And in case of ferromagnetic substances, if thin rod of ferromagnetic substance is placed in uniform magnetic field, then it quickly comes to rest with its length parallel to the direction of magnetic field. Next properties. In case of diamagnetic substances, the relative permeability is less than 1. In case of paramagnetic substances, relative permeability is slightly greater than 1. And in case of ferromagnetic substances, relative permeability is too much greater than 1. In other words, we can write the magnetic permeability mu is less than mu0 for diamagnetic. The magnetic permeability mu is greater than mu0 for paramagnetic, and the magnetic permeability is too much greater than mu0, that means permeability of free space in case of ferromagnetic substances. And from these two observations, as we know that the relative permeability mu r is equal to 1 plus chi m, that means magnetic susceptibility, and therefore the magnetic susceptibility for diamagnetic substance is small and it is negative. Small and negative. For paramagnetic substance, again the magnetic susceptibility is small and it is positive. And in case of ferromagnetic material, magnetic susceptibility is large and positive. So this is the another property of di-, para and ferromagnetic material. Magnetic susceptibility for diamagnetic material is small and negative. Magnetic susceptibility for paramagnetic material is small and positive. And magnetic susceptibility for ferromagnetic material is very large and it is positive. Next, diamagnetism does not obey the Curie's law, or diamagnetism is independent of temperature. Paramagnetic depends on temperature. That means there is effect of temperature on paramagnetic substance. And similarly, ferromagnetic substances, there is an effect of temperature on ferromagnetic substance. That means it depends on temperature. So Curie law is not verified or not obeyed by the diamagnetic substance. Curie law is obeyed by the paramagnetic substance, and Curie law is also obeyed by the ferromagnetic substance. If we plot a graph of temperature, absolute temperature against magnetic permeability for diamagnetic substance, then K is constant as it is independent of temperature. In case of paramagnetic substance, if we plot a graph of absolute temperature and magnetic susceptibility, the nature of the graph is like this. And for paramagnetic substances, if the graph is plotted against absolute temperature and magnetic susceptibility, it comes out to be like this, and this is the critical temperature for ferromagnetic substance. The next property of diamagnetic substance is diamagnetic substances cannot be used to prepare permanent magnet. Similarly, the property for paramagnetic, that is paramagnetic substances are not used to prepare permanent magnets, but ferromagnetic substances are used to prepare the permanent magnet. Again, in case of diamagnetic substances, domain are absent. In case of paramagnetic substance, same property, that means domains are absent. But in case of ferromagnetic, domains are present. Then in next article, we are going to familiar with domain of ferromagnetic substances. So, from the three categories of magnetic substances or materials, diamagnetism is the universal, and the diamagnetic materials at low temperature behaves like a perfect conductors and perfect diamagnetisms, and the effect is called as Misner's effect. So the substances belonging to the diamagnetism are superconductors, and in case of again diamagnetism, paramagnetism and ferromagnetism, we can say that in all the three cases, in the absence of external magnetic field, the net magnetic dipole moment is zero. In diamagnetic, net magnetic moment is opposite to the direction of magnetic field. In paramagnetic, the net magnetic dipole moment is feeble, which is in the direction of magnetic field, but in case of ferromagnetic substances, the net magnetic dipole moment is very large as compared to the diamagnetic and ferromagnetic, which is in the direction of magnetic field. Now,